Welcome learners. Now lesson today we look at sulfur and its compounds. Subtopic is sulfuric 6 acids. We look at industrial manufacture, physical and chemical properties of dilute sulfuric acid, then physical and chemical properties of concentrated sulfuric acid. So we begin by looking at industrial manufacture of sulfuric 6 acid, which is prepared by a process called conduct process. The raw materials are sulfur or metal sulfide, e.g. zinc sulfide, air, and water. Optimum conditions is temperature of 450 degrees Celsius, pressure of 23 atmospheres. Catalyst used is either vanadium 5 oxide or platinum catalyst. Note that vanadium 5 oxide is most preferred to platinum. Reasons: it is cheap and it is less easily poisoned by impurities. Therefore, look at disadvantages of platinum over vanadium 5 oxide. It is expensive and it is easily poisoned by impurities. Next, we look at the parts of the process of conduct process: burner, cleaners and dryers, heat exchanger, catalytic chamber, absorption tower, dilution chamber. Now, this reaction occurs in 4 stages. Stage 1 is production of sulfur 4 oxide, which occur at the burner. Here, sulfur or metal sulfide, e.g. zinc sulfide, is burned in air to produce sulfur 4 oxide. Equation is, when you are using sulfur, sulfur plus oxygen, arrow, sulfur 4 oxide. When you are using a metal sulfide, e.g. zinc sulfide, it becomes zinc sulfide plus oxygen, arrow, zinc oxide plus sulfur 4 oxide. Now, stage 2 is purification of sulfur 4 oxide gas. Now, this will occur at the cleaner and the dryers. Now, the cleaner removes impurities, e.g. dust particles, by a process called electrostatic precipitation. The reason for removing the impurities is so as to prevent poisoning of catalyst. Now, after that, the gases mixture is passed through the dryer, which contains concentrated sulfuric acid, which is used to remove water vapor, that is, dry the gases, because sulfur 4 oxide is highly soluble in water. Now, stage 3 is catalytic conversion of sulfur 4 oxide to sulfur 6 oxide. Now, the gases mixture of sulfur 4 oxide and air is passed first through the heat exchanger. Reason: so as to preheat the mixture of sulfur 4 oxide and air to attain suitable reaction temperature. After the preheating, the mixture is passed through the catalytic chamber, where it is further heated to a temperature of about 450 degrees Celsius, then passed overheated vanadium 5 oxide, where sulfur 4 oxide reacts with oxygen to form sulfur 6 oxide. The equation is 2 sulfur 4 oxide plus oxygen, arrow, 2 sulfur 6 oxide plus heat. Now, after that, we have stage 4, which is conversion of sulfur 6 oxide to sulfuric 6 acid. Now, the sulfur 6 oxide formed at the catalytic chamber is pumped back to the heat exchanger, where it is cooled, and then it is absorbed by concentrated sulfuric acid at the absorption tower to form oleum. The equation is as follows: sulfur 6 oxide plus sulfuric 6 acid give you arrow oleum. Now, the oleum is then diluted in large volume of water in the dilution tower to form sulfuric 6 acid. The equation is as follows: oleum plus water, arrow, 2 sulfuric 6 acid. Now, note the following things. Sulfur 6 oxide is not dissolved directly in water. Reason: the excessive heat produced. The reaction between sulfur 6 oxide and water is exothermic, i.e., the excessive heat generated could boil the acid to produce mist of fine droplets of sulfuric acid in air. Now, point number 2, the pollution effects of sulfur oxides is controlled by scrapping. That is, the chimneys are lined with calcium hydroxide, which react with sulfur oxides to form calcium sulfide and water. Now, the yield of sulfur 6 oxides is always higher at low temperatures. Now, disadvantages of operating at low temperature is the reaction is low. Now, the yield of sulfur 6 oxides can also be increased at high pressure. Now, disadvantage of operating at high pressure is the cost of maintaining high pressure is expensive. Industrial manufacture of sulfuric acid, that is by conduct process. The raw materials, which is sulfur and air, enters the burner. The burner, sulfur reacts with oxygen to form sulfur oxide. We can also have metal sulfide, e.g. zinc sulfide, which reacts with oxygen in the burner to form zinc oxide and sulfur oxide. So the sulfur oxide and air mixture is pumped into the cleaners, which remove dust particles. I say the reason for removing dust particles is to prevent poison catalyst. Then after that, it's pumped to the dryer. The dryer contains concentrated sulfuric acid, which is used to dry the gases mixture by removing water vapor, because they say the gas is highly soluble in water. Then from there, it is pumped to the heat exchanger, where the mixture is preheated so to attain suitable reaction temperature. Then to the catalytic chamber, where sulfur oxide is oxidized to sulfur 6 oxide, which is pumped back the heat exchanger for cooling. Then from the heat exchanger, it is taken to the absorption tower, where it is absorbed by sulfuric acid to form oleum. Then oleum is diluted in water in the dilution tower to form concentrated sulfuric acid, which is pumped back to the dilution. Now, physical properties of concentrated sulfuric acids include: it is a colorless liquid, it has a density of 1.84 grams per centimeter cubed, it boils at 338 degrees Celsius, it is very soluble in water, it is hygroscopic, hence used for drying of gases which do not react with it. Now, chemical properties of concentrated sulfuric acid include: 1. Dehydrating property. Definition of terms: dehydration. Dehydration is a process of removing water molecules or elements of water from a compound. Dehydrating agent is a substance which is capable of removing chemically combined water or elements of water from a compound. So examples where sulfuric acid acts as a dehydrating agent include: A. Hydrated copper sulfate. The equation is copper sulfate pentahydrate RO concentrated sulfuric acid gives you copper sulfate anhydrous plus 5 water. Now, observation made during the reaction. Observation made during the experiment is blue hydrated copper sulfate crystals changes to white powder. At the end of the experiment, a white powder is formed. Reason: concentrated sulfuric acid dehydrates blue hydrated copper 2 sulfate to anhydrous copper sulfate, which is a white powder. Example 2, sugar crystals. Equation: sugar equation is sugar C12 H22 O11 solid RO concentrated sulfuric acid gives you 12 carbon plus 11 water. Observation made: sugar crystals are charged to a black mass. Reason: concentrated sulfuric acid dehydrates sugar to carbon, which is black. Example 3, methanoic acid. Equation: Methanoic acid, that is HCOOH solid, arrow, concentrated sulfuric acid, CO gas plus water. Observation made, bubbles of a colorless gas is seen. Reason, concentrated sulfuric acid dehydrates methanoic acid to carbon 2 oxide. Now, property number 2 is oxidizing property. Concentrated sulfuric acid is a strong oxidizing agent, hence itself gets reduced to sulfur oxide and water. Example number 1 is reaction with metals, e.g. copper and zinc. I can give an example of copper. Equation: copper plus 2 sulfuric acid, arrow, copper 2 sulfate solution plus sulfur oxide plus 2 water. Observation made during the experiment: brown solid dissolves in the acid. A blue solution is formed. Bubbles of a colorless gas is seen. At the end of experiment, a blue solution is formed. Reason: concentrated sulfuric acid oxidizes copper to blue copper 2 sulfate solution while itself reduced to sulfur oxide gas and water. Now, reaction with non-metals, e.g. carbon and sulfur. I give an example of sulfur. Equation: sulfur plus 2 sulfuric acid, arrow, 3 sulfur oxide plus 2 water. Observation made, bubbles of a colorless gas is seen. Reason: concentrated sulfuric acid oxidizes sulfur to sulfur oxide while itself reduced to sulfur oxide and water. Now, physical properties of dilute sulfuric acid. Note that dilute sulfurics behave like a typical acid. Hence, the physical properties include: it changes blue litmus paper red, it conducts electricity due to presence of permeable ions, it has a sour taste, it has a pH of 1 or 2 or 3. Chemical properties of dilute sulfuric acid include reaction with metals. Example: zinc plus sulfuric acid, arrow, zinc sulfate plus hydrogen gas. Observation made during the reaction: the presence of gas due to production of hydrogen gas. 2. Reaction with bases. Now, metal oxides, example can give is copper 2 oxide plus sulfuric acid, arrow, copper 2 sulfate plus water. Now, bases react with acid to form salt and water by a reaction called neutralization reaction. Last is reaction with carbonates. Now, I give an example here: sodium carbonates plus sulfuric acid, arrow, sodium sulfates plus CO2 plus water. Observation made, have a basis of gas due to production of carbon dioxide gas. Learners, that is the end of the lesson. The next lesson, we're going to look at hydrogen sulfide gas.